Hello everyone. أكيد أنا وحشتكم جدا جدا وانتوا يعني وحشتوني سنة يعني I have to admit. Don't worry, I am grading your exams. I'm not forgetting that for tomorrow when I come in, you're gonna get your exams. Um, I do want to say as well, make sure you are writing your questions as we go. لأنه if you have questions, I'd love to know them when I come. You could feel free to email me بس أنا مش بعرف أشرح through email anyways. يعني كمان it will be harder for you to understand whatever I'm going to say through email. So it's better if you write your question down in your notebook and you ask me when I'm back. تمام؟ طيب النهاردة we are going to continue on calorimetry. Again, as we agreed yesterday, calorimetry is one of the most important fields of chemistry because it's so close to our day-to-day lives. It's really close to how we calculate our nutrients. In fact, there is a law worldwide that if you are selling any product, we have to be able to determine the amount of calories in it. This is a law that exists worldwide. So imagine if we didn't know how to do that. Imagine if we didn't have the chemistry available to do that. So that's why the field of calorimetry is really, really important. So we are going to continue on that today. Again, as I always say مع كل unit, new unit, fresh start. Let's say you haven't been doing very well in my class. Oh, I'm on unit 1, unit 2, unit 3, you weren't doing that well. Unit 4, you can do well. Let's not lose hope. Okay? Again, new unit, fresh start. Come sit up front, focus, take your notes out. Use this as a motivator to start fresh and to actually start focusing بجد. And I'm here to support you. You know that, always. Okay. So I am gonna share my screen right now on the slides. Type. Again, let's quickly review. What is calorimetry? Calorimetry is the process of measuring energy changes during a physical or a chemical change. Remember, we had mentioned specific heat capacity earlier. And we mentioned that the fingerprint of the substance, the fingerprint of water, is that it has a specific heat capacity of 4.18. The fingerprint of ice is 2.03. The fingerprint of aluminum, and how do we measure that? We measure the amount of energy it takes to increase 1 gram of the substance by 1 degree Celsius. So 1 gram يعني كأني أنا بقى هجيب gram من الحاجة and I'm gonna heat it up. I'm gonna first measure its initial temperature and then I'm gonna heat it up by 1 degree Celsius. And I'm gonna see how much energy did it take me to heat this up by 1 degree Celsius. Okay? Calorimetry is that process. It's the process of measuring energy changes during a physical or a chemical change. Now, oh, does it actually stop here? No, it doesn't. Wait, I don't know why it's glitchy. Let's exit and reload. Oh, it's a video. Mr. Dave explains. So I'm not sure. I don't think it's gonna load, guys. I think this video no longer exists. Yeah, I think this video no longer exists, but we already explained heat capacity, so you do not need to see the video. Okay? Type. What happens in calorimetry? We have 3 different types of calorimeters. Okay, we call it calorimeters or calorimeters if you want to pronounce every single letter. Now this is called the coffee cup. This one right here is called the coffee cup calorimeter. Okay, notice there is a thermometer right here to measure the temperature because we want to measure the increase in temperature. There's a cover and that cover allows it to be a closed system because in order to measure the transfer of heat, I want to limit the transfer of matter so I can make sure I'm only changing one variable. Remember in math, كنا دايما بنقول if I have two unknowns, I can never solve the system. This is the case here as well. If I do not make the system a closed system, when I get my data, I will not be able to identify if this is a correlation or causational, or if the cause was the mass evaporate, like the mass, if it's water evaporating, or the cause was the breakdown of like the solid or something like happening to it and changing the actual matter. Normally, evaporation is the most realistic thing we could say about open systems. But I have to make it a closed system, lekin I want to allow the transfer of energy. Because that's what I'm trying to measure anyways. Okay? And normally we have a stir, so we can make sure that it's a homogeneous mixture. Remember, homogeneous, heterogeneous. Homogeneous is the same state, because you want to make sure you are increasing the temperature of the whole mixture, of like the mixture of things, not just one part of the mixture because it hasn't been stirred properly. This is another calorimeter, and this right here is the oldest calorimeter that was made. It's made of metal compared to like a styrofoam cup. Okay, and obviously this would be the industrial grade of calorimeter that we use. طيب هو ليه مش عايز clear my drawings استنى. So we have a few things that affect the amount of heat that's released from a substance. We have a few factors. First thing, and remember, those are my favorite multiple choice questions. I love to trick you using those questions, so make sure you're focusing with me on that. Excuse me. So a calorimeter, three factors that affect the Q, which is the heat, whether it's absorbed or released, are the mass of the substance, the specific heat capacity of the substance, and the temperature change experienced. طيب. In a calorimeter, actually the goal is to fully burn the substance. Remember heat capacity كانت I'm checking how much energy it takes to increase the temperature by 1 degree Celsius of 1 gram of the substance. In a calorimeter, I actually fully burn the substance that I have. I do want to show you a video, but I'm just going to first explain the factors affecting it, and then I'm going to show you a video to demonstrate that. So factors affecting Q, the amount of thermal energy absorbed or released. One, the mass of the substance. How much do I put of it? لو أنا حطيت كتير, obviously it's going to affect the amount of heat released from the system and absorbed in the system. لو أنا the specific heat capacity of the substance is high, طب it's going to take a lot of energy before it can increase the temperature by even 1 degree, which means that it's going to take in and absorb a lot more heat. If the temperature change experienced is so drastic until I burn that substance, this means that it has a lot of heat absorbed or released. And that the last one kind of makes sense, right? And this takes us to the point that the equation for Q, which is the amount of thermal energy, and remember energy, thermal energy absorbed or released by a system, is MC delta T. And I'll tell you a story to help you remember the MC delta T. When I was in university back then, way back then, I took a big exam. It was an 8-hour exam that's used in Canada in order to apply to medical schools. Okay? It was an 8-hour exam, you guys. It had, I don't even know how many sections. It was like 4 sections. Yeah, it was 4 sections. And then you sit through 2 hours of each, and they would grill you questions that are not even memorization based. They'd give you like a big essay and you're supposed to get scientific data from it. Of course, not an essay like an English essay. They'd give you like experimental data or a research paper, and you're supposed to deduce so many things out of it. You're supposed to talk about like diagnosis of different diseases based on what you know in biology. So it was a really, really complicated exam, an 8-hour exam. What was that exam called? It was called the MCAT. In the MCAT, they grill us. In the MCAT, they really, really grill us. What does MCAT stands for? It stands for Medical College Admissions Test. Okay. And I remember doing that exam, and we had like between every section, we had a 5-minute break. So I would go outside and I would run up and down the stairs. So I could like increase the blood flow to my brain. But literally, they grilled us in that exam. And I did very well. I scored in one of the, I think it was the 80th percentile. So I got a score higher than 80% of the people that take this exam generally. Of course, I could do better. I could do better. Okay, why am I telling you that story? Because every single time I see that formula, I remember the MCAT. MCAT. What happened in the MCAT? They grilled us. Q. Q is the amount of thermal. Thermal means temperature. So they grilled us in the Q in the MCAT. So that's one way of remembering that equation. Okay. And one way of remembering the factors that affect the amount of thermal energy absorbed or released. Mass, specific heat capacity, and please, 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 I beg you, do not confuse C for concentration, because it's not concentration. It is specific heat capacity. So please make sure you are focusing very well that this is specific heat capacity, not concentration. And over here, this is the temperature change experienced, the delta T. Now, let's talk about units for a moment here. What do you think the temperature has to be? Let's think about it. And please, guys, I noticed in the exam, you guys don't really like to think. Like you want to be told the answer. I want you to learn how to problem solve. So when you see something and you're stuck, try to invent strategies to solve the question. Whether it's by process of elimination, whether it's by trying out different methods, whether it's by highlighting different parts of the problem and trying to understand what it's asking. So I noticed that if you, like on the exam, when people just got shocked by reading the question, their brain stopped. I don't want that to happen. I want you guys to work on your problem solving skills. But anyways, exam aside, I want to talk about how do I figure out the unit. So remember the unit for C was grams per degree Celsius. Let's actually go back to it. Joules per gram degree Celsius. See, it was good that we went back to it. So joules per grams of degree Celsius. Joules divided by grams multiplied by degrees Celsius. Does that show you something kind of special? Over here in this equation, I am multiplying by mass and I'm multiplying by delta T. Mass, delta T, degrees Celsius. So that tells us that the unit for mass in this equation, it has to be grams. And it tells us that the unit for delta T in this equation has to be degrees Celsius. So if I give you Kelvin, you have to change it to degrees Celsius. You can't keep it as Kelvin. Does that make sense? Alrighty. So how do I interpret data from a calorimetry experiment? And I will also explain to you how to actually do the calculations, and we're going to try out some calculations together. But for now, I want you to learn how to interpret the data. So in calorimetry, the magnitude of Q, and remember Q is energy, hence why the unit for Q is joules. Okay, so I do want to stress that in MCAT, the unit for Q is joules. The unit for mass is grams. The unit for temperature is degrees Celsius. So the magnitude of Q, it tells us how much energy is involved. It tells us how much energy is involved. So regardless of whether or not it's positive or negative, the magnitude tells us if there is a lot of energy involved or very little energy involved. Okay? Now, how about if it's positive or negative? If it's positive, it means it's releasing heat to the surroundings. You know, when someone's being positive, Habiba is an extremely positive person when you see her. So Habiba releases energy to the people around her. She releases positive energy to the people around her. She releases, I wouldn't say heat, I would say then. And so applying to this concept, positive Q means I'm releasing heat, I'm releasing energy to the surroundings. Okay? That also means that the T of the substance is increasing. Hence, it's endothermic. So it is releasing energy to the surroundings, great. But to itself, it is taking in energy. Wait, let's think about this again. I feel like I confused you guys. The T of the substance increases, hence it's endothermic. If I have a positive Q, if we take a look at the equation, MC delta T, this means that I end at a higher temperature compared to what I started with, which means I am taking in heat. So the system is taking in heat. Okay? Actually, ignore the previous example that I just said. Sorry, Habiba, you're positive and you're amazing. We all know that. But I said the wrong example for this one. I meant something else. But for this one, for Q value, if it's positive, this means that the T of the substance increases, hence it is endothermic. It ends at a higher temperature compared to what it started. طب التمبerature دي الانكريز ده جه منين؟ جه من knowing إنه it's taking in heat, which is endothermic. And negative Q means that it's the temperature, I'm ending at a lower temperature compared to what I started with. يعني I'm losing heat. Losing heat كانت ايه الكي word بتاعتها؟ Losing heat is exothermic. So a negative Q means that the T of the substance decreases, hence it is exothermic. Okay? طيب. I want to give you a few moments. Try to apply what we just learned. I'm going to write the equation. MC, and I'm going to write delta because I don't have delta in my keyboard. So I'm going to write Q equals MC delta T. Okay? Where delta is this triangle right here. Now, if a question tells you a student places 50 milliliters of liquid water at 21 degrees Celsius into a coffee cup calorimeter, she places a sample of gold at 100 degrees Celsius into the calorimeter. The final temperature was 21 degrees Celsius. Okay. The specific heat capacity of the water is 4.18, and the density of the water is 1 gram per milliliter. Calculate the quantity of thermal energy absorbed. Now, I want to give you 5 minutes. Try to brainstorm what we could do here. This is consider a mathematical word problem. I don't want you to overthink this in chemistry. I want you to think of it as a math problem. And you were given a problem, you know your units. How could I potentially be solving this question? Okay. Now, just a heads up before you start brainstorming this, in a calorimeter, it's normally double cups. Okay. In here, I put the substance and then I surround it with water. How do I measure? Like, so I burn the substance and then I measure how much did this temperature of the water change? And of course, I know the heat capacity, the specific heat capacity for water is 4.18. This is a constant. And the density of the water would depend on how much I put of it, or the mass of the water would depend on how much I put of it. The density of water is always one. Okay? So given that information, given that understanding of a calorimeter and how a coffee cup calorimeter works, now I want you to take 5 minutes. Sorry, whoever's subbing for me, if you could please set a 5 minute timer. And thank you so much for doing what you're doing. I really, really appreciate you subbing for me. Um, if you can, set a timer for 5 minutes. And guys, I want you to really critically think. Again, I want to start developing your problem solving skills because I am noticing that we are very weak on that end. Okay? You got 5 minutes. Try your best. You can stop the video now and start trying this question after 5 minutes, replay the video. Okay, guys, so I hope you are done thinking at least about the question. You don't have to have an answer, but at least you have a rough idea of what you want to do in this question. Okay? Now, the question is saying, again, a student places 50 milliliters of liquid water at 21 degrees Celsius into a coffee cup calorimeter. She places a sample of gold at 100 degrees Celsius into the calorimeter. The final temperature of the water is 21.33 degrees Celsius, and the specific heat capacity of the water is 4.18 joules per grams degree Celsius. Now, the density of the water is 1 gram per milliliter. Calculate Q. Now, the moment that I read the word calculate Q, and I want to show you how my brain thinks about these problems, the moment that I read the word calculate Q, I immediately wrote my equation. So Q equals MC delta T. Okay, and then I'm going to check the question. What do I have? What do I not have? So I'm going to check. Okay, the question gave me a couple of temperature like values. Actually, in fact, they gave me 3 temperature values. So that's a little confusing, but hey, I'm just going to highlight them, which means that delta T very likely is covered. Okay, now C, I know that C is specific heat capacity. I also know that in a coffee cup calorimeter, I am measuring the change in temperature of water, which is surrounding the mass that I have. Okay? So given that I'm measuring the temperature change of water, this means that I need the specific heat capacity of water, and my brain should immediately recall that specific heat capacity is a constant. So I should be given this value, or if I'm given a table, or I should be able to Google it, you should be able to find this value. So C in this case, the question did give us C. It is 4.18 joules per gram degrees Celsius. Now the last part and the last variable that I want to check if I have is M. M is standing for mass. Mass of what? What am I measuring the change in temperature of? I'm measuring the change in temperature of the water. And notice the question never gave me the mass of the sample of gold, right? So I'm measuring the temperature change of water. So in this equation, I would add the mass of the water. Did the question directly give me the mass of water? No. No. Now I will look at my values and I want to see, is there any way I could deduce the mass of water from the data that I have? I immediately noticed that over here I've got grams, which is the unit for mass, but it is divided by milliliters, which is not what I want. I want grams without the milliliters. So how could I get rid of milliliters in this case? Think about it. Again, we want to develop those problem-solving skills. Well, one way I could do that is I need to multiply by milliliters. And that's exactly why the question told us that we added 50 milliliters of water. It says the student placed 50 milliliters of water, blah, 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 blah. Okay, so then I could find the mass of the water added by multiplying 50 milliliters by 1 gram per milliliter. And that would give me 50 grams. This means I added 50 grams of water. Am I ready to solve right now? Yes. Yes, we are ready. Except we didn't really decide which temperature values we are going to use. Okay, so which temperature values do we want to use? What am I measuring the delta T for? Remember, I am measuring the change in temperature of the water. So the question is telling me that the student placed the liquid water at 21 degrees Celsius. So this means that I'm starting at a temperature of 21 degrees Celsius. And then it's telling me in the question that the final temperature of the water is 21.33 degrees Celsius, which means that the final, so T final is 21.33. And the T initial for the water is actually 21 degrees Celsius. All of that is from the question. Now, again, please practice reading your questions like in a critical way. I could get you the exact same question on exam and slightly change the wording. This should not throw you off. Okay? So that's going to be Q equals 50 grams times 4.18 multiplied by delta T. And remember, any change ever in any equation ever is final minus initial, always. So that's going to be 21.33 minus 21, which is going to be 0.33. So if we calculate that, لو أنا كنت في الكلاس كان حمزة دلوقتي بسرعة طلع كالكليتر حلها معايا نبقى هنا. So it's going to be 50 times 4.18 times 21.33 minus 21. And that's going to be 68.97. Now, what will my unit be? Think about it. What will my unit be? My unit will be joules, right? So it's going to be 68.97 joules. Does that make sense? Take a moment, read the question, look at my answer. If you have any questions, ask the person next to you if they know. If nobody knows, email me or wait for me. I'm going to answer your question tomorrow. But I want you to look at the answer and critically think about it. Okay. Type. Let's move on. I hope there's one more question in the slides that you can. Oh, there you go. My wish just came true. All right, we are going to spend 10 minutes. So on a timer, you are going to have 10 minutes to solve this question. Okay, so thank you to whoever subbing for me. Please make sure you set a 10-minute timer, and you're gonna have 10 minutes to solve this question, and you're gonna input your answer into the form. Deal? All right, guys, pause the video, 10 minutes, turn the video back on. Okay, now this question is continuing on to the previous question. So I want to bring back our answer. And it's saying the following: using the value of Q that you calculated in problem 1, calculate the specific heat capacity, C, of the sample of pure gold if its mass is 6.77 grams. Assume that the final temperature of the gold sample was the same as the final temperature of the water in the calorimeter. And we know that we started at 100 degrees Celsius. And we also know that the final temperature for the water was 21.33. So this means that we know it's 68.97 joules. Now here's the deal. Let's think about the structure of the coffee cup calorimeter. We found that the Q of water was positive, which means that the water is endothermic. It's taking in heat, right? That means that the Q for the gold, which is right here, this has to be what released the temperature, right? So this means that the Q for gold is going to be exothermic. It's going to be the one releasing the heat into the water. Exothermic means that Q is going to be positive or negative. Exothermic means the temperature of the gold sample, the final temperature, is lower than the initial temperature, which is exactly what we see from the temperature values given, which means that Q is going to have to be negative. So I know that Q, they told us it's the same value for Q of water, so I'm going to put QW, same value for Q of water, but it's the negative version of it. And then the question is asking me for C, but it's giving me M, the mass, at 6.77 grams. And it's asking for C, and it's telling me that delta T is going to be 21.33. And again, always remember it's final temperature minus initial temperature. So that's going to be that is gonna be, sorry, I'm bringing my calculator. So that's gonna be negative, uh, negative 68.97 divided by 6.77 times bracket 21.33 minus 100, close bracket, close bracket. That gave me that the heat capacity for gold is 0. Roughly, if we round to 3 decimal places, is 0.129. Now, what's the unit for heat capacity? As always, it's joules per gram degree Celsius. Does that make sense? Now, again, Take a look at my solution. If it's not what you got when you tried this question, try to think about why. Why did you not get this value? What could have gone wrong? Okay? Type sample problem 3, that's going to be your observation. And I'm going to do this in class when I come. So you're going to spend another 10 minutes on this question. And you're going to record your answer through the Google form. Give me a moment. I just want to check what else do we have in. I think we could end it here on that problem. So you've got 10 minutes. I want you to try and solve this question. Input your answer in the Google form. Input an explanations. Notice part B is saying state of their actions, exothermic or endothermic. So input what you find, and we are going to discuss that when I come in during class. All right, guys, I hope you were focusing today. I hope you understood the lesson. It's a very simple lesson. It's a very cool lesson. If you are already done, I recommend you Google calorimetry because we are going to do a calorimetry experiment in the lab. So I recommend you spend some time Googling calorimetry, especially the coffee cup calorimeters, and get excited because we are going to do this together as well. Alrighty, guys. You take care. I hope you enjoyed class, and I shall see you tomorrow. Bye.